Myself, Rajendra Karale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about first law of thermodynamics. Which is also called as law of conservation of energy. Now, first law of thermodynamics is simply law of conservation of energy. The various statements of first law of thermodynamics are given below. That is, first statement is energy can neither created nor destroyed but it can be transferred converted from one form to another. Now, this was already discussed in the introduction by using the various example. Second, the total energy of the universe remain constant. Third, the total amount of energy of a system and its surrounding must remain constant although it may change from one form to another. Fourth, the energy of an isolated system remain constant and fifth, when a quantity of energy is disappear in one form and exactly equivalent amount of energy will appear in another form. Now these are the various statements of first law of thermodynamics. Now here write down justification for the first law of thermodynamics this is only for NEET and JEE. Now here it has no theoretical proof, but based on human experience and has not yet been violated. So listen here. First law of thermodynamics has no theoretical proof. That first law of thermodynamics is based on human experience and has not yet been violated. Now, the important statement of first law of thermodynamics is that energy can neither created nor destroyed, but it is converted from one form to another form. If the statement of first law of thermodynamics is true, then it is not possible to construct a perpetual machine which can do work without the use of energy. Now listen here. It is not possible to construct a perpetual machine which can do work without the use of energy. That means whenever the machine, any machine perform work, it is use energy. That means here, if the first law of thermodynamics is true, it is possible to construct a perpetual machine which can do work without the use of energy. That means here, second, James Joule in 1850 conducted a large number of experiments regarding the conversion of work into heat. That means here he concluded that when 4.183 joule of work is done, on the system by the surrounding produce 1 calorie of heat. So 1 calorie is equal to 4.184 joule. Now here he concluded that the same amount of he concluded that the same amount of work is done on the system by the surrounding irrespective of how the work is done. Produce same amount of heat. Now here, third point is that energy is conserved in chemical reactions. Now let us consider the example 1 here. Decomposition of one mole of water into hydrogen and oxygen gases by the absorption of the electrical energy equivalent to 286.4 kilojoule per mole of energy. That means here, write down the reaction. H2O liquid gives H2 gas plus half of O2 gas, and here delta H equal to plus 286.4 kilojoule per mole. Now, first justification is about the machine. Second justification is about the conversion of work into heat. And the third justification is about the energies conserved in the chemical reaction. That means here, when 1 mole of water undergoes decomposition, this much amount of energy is used. Suppose this reaction is formed in the reverse opposite direction. That means when 1 mole of water is formed, then how much amount of energy is released? That means here the same amount of energy is released. Meaning is that energy is conserved in chemical reaction. That means here example B, here formation of formation of 1 mole of water from hydrogen and oxygen gases by the liberation of energy to 6.4 kilojoule per mole in the form of heat. That means here H2 gas plus half of O2 gas gives H2O liquid, and here delta H equal to minus 286.4 kilojoule per mole. That is here, during the decomposition of 1 mole of water, the energy is used in the form of electrical energy, while during the formation of 1 mole of water, energy is released in the form of heat. And keep in mind, the energy is nothing but the capacity to do work, and most common form in which the energy appear is heat. That means there are two important forms of energy, heat and work. Heat is the random form of energy and work is the organized form of energy. Now we write down formulation of first law of thermodynamics. Formulation of first law of thermodynamics means mathematical expression of first law of thermodynamics. The internal energy of a system changes in two different ways. Number one, by transfer of energy in and out of a system in the form of heat. And by performing work on the system or by the system. That means here the internal energy of a system changes in two different ways: by transfer of energy in and out of system in the form of heat, and by performing work on the system or by the system. Now let U1 be the internal energy of system in the initial state, Q be the amount of heat absorbed by the system and W be the work done. That means suppose this is the system, U1 be the internal energy of the system, Q be the heat absorbed by the system, and W be the work done. That means here, let us consider number A. Work is done on the system. That means here when work is done on the system, the internal energy of the system in the final state U2 is, that means U2 is equal to U1 plus Q plus W. Here U1 is the internal energy in the initial state, Q is the amount of heat absorbed, and W with the work is done on the system. That means here U2 minus U1 equal to Q plus W. But here U2 minus U1 equal to delta U, and hence delta U equal to Q plus W. This is your equation number A. That means your change in internal energy equal to heat added to the system plus work is done on the system now second when work is done by the system, that means here when work is done by the system, the internal energy of the system in the final state U2 is, that means here U2 equal to U1 plus Q minus W, that is U2 minus U1 is equal to Q minus W, but here U2 minus U1 is equal to delta U, and hence delta U equal to Q minus W. This is your equation number B. That means here change in internal energy equal to heat added to the system plus minus work is done by the system. That means here now this relationship is a mathematical statement for first law of thermodynamics. That means here the first law of thermodynamics for an infinitesimal changes in the quantities is given as, that means here du equal to dq plus minus dw, where du is the infinitesimally small change in internal energy. Second, dq is the infinitesimally small change in heat and dw is the infinitesimally small change in work. Now this is regarding about the first law of thermodynamics, which is also called as law of conservation of energy. There are various statements, their justification and formulation of first law of thermodynamics. Formulation of first law of thermodynamics means mathematical expression for first law of thermodynamics, that is delta U is equal to Q plus W, is applicable when work is done on the system, and delta U is equal to Q minus W is applicable when work is done by the system. That means internal energy of a particular system changes in two different ways. That means number one, by transfer of energy in or out of system in the form of heat, and by performing work on the system or by the system, and the remaining part of this unit will be discussed in the next lecture.